In the language of math, we use a lot of statements that are known as conditional statements. A conditional statement, by definition, is any statement that can be written in an if-then form. And conditional statements always have what's called a truth value, meaning the statement is either true or it's false. For example, here's a statement that we use at my house sometimes. If you are late, then you will not be able to go out on Friday night. And that statement is either true or false, depending on the rules of your house. But it's called a conditional statement, and you can see there are the two parts of that. You see the if, and there is the then. So, breaking that down a little bit further, a conditional statement always has a hypothesis and a conclusion. The hypothesis in this case, it's setting up the conditions of the statement. And again, in this case, the hypothesis is you are late. And the conclusion then makes a claim about the results of the hypothesis. In this case, you will not be able to go out Friday night. And so the two parts, hypothesis and conclusion, another way to help you understand a conditional statement is you can draw a Venn diagram with these two circles. You see one. In a Venn diagram, the circle and the smaller circle shows us what the hypothesis is. In this case, you're late. Well, what is a direct result of being late? In other words, if this happens, what else do we know is going to automatically happen, which is shown by our bigger circle? We know that if you're late, then automatically you can't go out on Friday night. So that's a diagram, a Venn diagram of the statement. And another way to do this is kind of outline it. You can take your hypothesis, if you are late, and then we draw what's called an implication arrow. And being late implies that you can't go out on Friday night according to this statement. So in basic terms, your hypothesis leads to your conclusion, and that's what this arrow means. Again, that would be read implies. Hypothesis implies conclusion. Let's try another one. Now, this is a conditional statement, but you notice it doesn't have the if-then form. You have a sibling if you have a twin. Just because it doesn't have the if-then form doesn't mean it can't have the if-then form. Remember, a conditional statement is any statement that can be written in if-then form. So in order to do this, we want to identify the hypothesis and the conclusion. Which part of this leads to the other one as an automatic result? Well, if I am in the smaller circle of having a twin, then I have a sibling. So the hypothesis is I have a twin. And you can see that it's again introduced by the word if. Now if I have a twin, putting me in the smaller category, does it generally lead to conclude that I have a sibling? And the answer to that is yes. So that's what this statement is saying. If I have a twin, then I have a sibling is another way to say that in if-then form. If you have a twin, then you have a sibling. So this form is a little bit different. This is the form that looks like conclusion if hypothesis, because the hypothesis is written after the conclusion. Sometimes you'll see mathematical statements written that way. Let's try this example. Every planet rotates around the sun. Can that be written in if-then form? Of course it can. What is the condition? What is the hypothesis in this case? Is it being a planet or is it rotating around the sun? Every planet rotates around the sun can be broken down this way, with the hypothesis being that I have a planet or I've got a planet that I'm looking at. And then if it is a planet, then it automatically will rotate around the sun. So the hypothesis and the conclusion in this case are something as a planet is the condition, and then it would make sense to conclude that it would then rotate around the sun. So in if-then form, we have if something is a planet, then it rotates around the sun. So in general, we have a few different forms that we might see a conditional statement in. The most common way to do it is the if-then form. If followed by the hypothesis, then followed by the conclusion. In symbol form, that looks like H, hypothesis, implies, using that arrow, conclusion. Hypothesis leads to the conclusion. And as a Venn diagram, we would have an inner circle with our hypothesis, and if I'm in that inner circle, I'm automatically in the bigger circle, so that automatic conclusion will happen. Going back a little bit, an alternate form of an if-then conditional statement might look like condition stated if the hypothesis happens. And of course, you can also use the word every or all to write an if-then statement. Those can be a little tricky. We'll need to practice. So here's one for you to try. I want you to give this a try before you go on. So pause the video and try to rewrite the conditional statement so that it's not in if-then form. Right now, we do see the if and the then. So your job is to rewrite it, maybe using the word all or every, or using that alternative form with condition if hypothesis. So break it down, and then after you've rewritten it, look at it again and decide, do you think this statement is true or if it's false? Every conditional statement is either true or false. What do you think about this one? If it is false, go ahead and give a counterexample. Pause the video and try it now. All right, let's see how you did. Here is my Venn diagram, and I would say that on this, if a figure has exactly 3 angles, then it is a triangle. The hypothesis is a figure has exactly 3 angles. It is always going to be introduced with the word if. And the conclusion would be it is a triangle. So if we want to write it in that conclusion if I want to write it in that conclusion if hypothesis form, then it would look like this. A figure is a triangle if it has exactly 3 angles. Or maybe I want to use the word every or all. From the Venn diagram, we can see that every time I'm a figure with exactly 3 angles, I'm automatically a triangle. So I set it as all figures with exactly 3 angles are triangles. Do you think that statement was true or false? Every time I draw a figure with exactly 3 angles, is it automatically a triangle? That is a false statement. In this counterexample, we can see 3 angles in the figure, not a triangle.